no doubt, exactly 68.6 centimeters. That is my weight. So I put the little head here. So that's my weight. 6.86 newtons. And then parenthetically 68.6 centimeters. And I'm going to double check that to make sure I'm not off. Since I didn't start at 0, I started at 20. So 20 plus 68 would be 88. Oop, I did not go far enough. All right. Next one, add the normal force. Well, I know the normal force is at a tilt here. So the normal force is going this way. It's perpendicular to that 30-degree angle there. So therefore, let's see, let's draw some triangles. I got that information. So that's 30 degrees. So therefore that's 60 degrees. And presumably I can make it darker than that. So that's 30, 60. That's a 60-degree angle. Therefore that's a 30-degree angle. So I need to do 30 degrees from the weight there. Does that make sense? Yeah. We'll deal with that later. So my normal force is going to be in this direction here. Now it's not going to go all that entire distance there. But how far does it go? Well, again, if we knew trig, we could calculate it, but we don't have that under our tool belts for everyone. So we need to throw in the friction. I know friction is going to be at this 30-degree angle here. And if I can get this thing off, there we go. So I know friction is going to be along this line right here. Because again, I have this triangle that I'm sort of, well, the pseudo triangle that I'm trying to create, which means the normal force stops here. That's where the normal force stops. There's my normal force. We now have to figure out what is the actual normal force. Well, we have a scale, we measure the length. And I'm getting 60.1 centimeters, which would correspond to 6.01 newtons. I know my resultant is going to be 1.309 newtons. So I'm going to draw my resultant, which will be roughly 13.1 centimeters. So there's my net force. And therefore, my friction must be the gap between my normal force and my total force. Because again, this is basically what I'm trying to draw here, except more accurately. So I have weight acting down, normal force at an angle, friction acting at an angle, and we get that result. So I can now measure the friction force. The length of the friction force is (20.8). So this is 20.8 centimeters, which corresponds to 2.08 meters. I know the excitement's building here. We're about to find out what the coefficient of kinetic friction is between the book and the table. Woo! And now we go to the formula. Kinetic friction is equal to this coefficient of kinetic friction times the normal force. My kinetic coefficient is, oops, somebody should have said something. It's newtons there. So this is 2.08 newtons equals my kinetic coefficient, u sub k, times my normal force, 6.01 newtons. Divide by 6.01. So we get u sub k equals 608 units. Newton squared would be newtons times newtons. What are the units?
Centimeter?
No. Think about the math problem that was done to get to 0.34608.
Well, the newtons would cancel. Yeah.
Therefore, the units are
Nothing.
nothing.
Oh. Trick question.
You could, if you said newtons per newton, that also would have been the correct answer. Just usually they don't give you any units afterwards. Now, with more precise measuring, you get better results. And also, if I were doing this as part of an actual project I was doing, I'd be using trig. But the essence of how you find the coefficient of kinetic friction, we did just then. You put an object, you take the two objects, you slide one against the other, and the friction is the difference between the ideal and reality, and you calculate it. To find the static coefficient of friction, you do something very similar, except the static, we want it to not slide, in a sense. So here's how you find the static coefficient of friction. Oh, questions on this before I talk about how we find static? Which I probably should have done first, but didn't. So here's how you find the static coefficient of friction. You put the two objects together, and then you start lifting. and you've tried to figure out that point where it's starting to slide. Because right now, static friction is keeping it from sliding, but it's not at that maximum point. The static friction keeps increasing, and it will keep increasing until it starts to slide. So there's some angle which it will start to slide. Once you know that angle, use trig or just do it with a protractor. It's very similar, except the theory, the way you work it is that angle where it starts to slide is so close to the angle where it wasn't sliding that we treat them as the same. So once you know that angle, then you can find out the static coefficient. And I'm actually curious. I am going to use a little bit of trick here instead of going through. I know all of you would really love just to do the drawing again. However, yes, this is just absolutely perfect. It's about a 26-degree angle. And it turns out that mu sub s is just the tangent of whatever angle is that critical angle, just theta sub c, that critical angle, which I said was about 26 degrees. If someone has tangent on their calculator, or if no one does, I guess I could do it. Please work out, please work out.
Would 0.477 be about right? 0.4877, sorry.
Wait, what is it again?
It's really long, but the first four are 0.4877.
4877.
I heard something completely different.
What'd you get?
1.1787. What mode?
I-
I'm probably going wrong there.
If you're probably, it's going to be something less than 1. So this number seems reasonable, and partly because I just wanted it to be something bigger than that one. Good now? All right. So notice that my static coefficient of friction is bigger than my kinetic coefficient of friction. It should be that way. This should never be less than that, despite half the friction labs I've ever had students do. And I've actually tried to find some of the professors in the graduate school where I was were claiming that these two numbers really should be really close to each other. And so I tried to find anyone who had done precision measurements on this, and I found one college senior who did a project on this with error bars and went through the statistical analysis, but there were so few trials that it was not as thorough as I would have liked. Again, it comes down to physicists don't deal with friction a whole lot, and engineers have something that works. So the more depth studies just aren't being done. All right, questions on friction? All right. So that was a deeper exploration of forces and Newton's second law. Let's talk about Newton's third law. The law which is so badly mangled. Flashing back. But last time I taught in middle school, I was trying to find a video which really illustrated Newton's third law really nicely. And I found they looked like they could be 8th or 9th graders who posted, they were in a bowling alley and they had the bowling ball being returned. And when the ball comes up, it hits another ball and the ball moves on. At that point, they talk about action, reaction. The action is this ball hit that ball. The reaction is that ball moved. No! That is not Newton's third law. Now, I don't know what's going to be more horrifying. Whether they thought, wow, we really nailed it, let's post it for everyone to see. Or if the teacher said, why don't you post it? Or maybe the teacher was thinking, yeah, why don't you post it? Let everyone see. And it's done in one of the videos that I've done. Reaction in the terms of physics is not the same as reaction in terms of everyday life. I think the example I give in the video is, if a ghost suddenly appeared, I'd probably go, oh. My reaction is that is not what Newton's third law is about. I heard someone once justified mass murder using Newton's third law. The person was pushed to the point where he just lashed out. It was an equal and opposite reaction. It was natural. His reaction was natural to what he was been put upon. And in this particular case, you could make an argument that his reaction was justified. However, it's not Newton's third law. So, a book pushes down on a table with 5 newtons of normal force. We'll just start out with a simple statement. This is not Newton's third law. This is just, I have 2 objects. I have a force, direction. So, what are the 2 objects involved in this exchange of force? All right, so I'm book and table. What is the source of the force? And what is the receiver?
Both is the source, cable is the receiver.
Right, okay. So the source and the receiver. What is the direction of the force?
Down.
What is the magnitude of the force?
5 minutes.
And what type of force is it? If we wanted to apply Newton's third law, we swap the 2 objects and we change the direction. And then our statement will be true. So we sought the receiver and the source. So a table pushes up, because I switched the direction, on a book with 5 newtons of normal force. That is an application of Newton's third law. We've already done it. When we did the force diagrams, I talked about forces coming in pairs. This is just a formality right here. And at some point, this became sort of a standard question I asked on a lot of tests. I'd give a sentence and then say, applying Newton's third law, what would the new sentence be? This is what I'm doing. You switch the objects, you switch the source and receiver, change the direction, everything else is the same. When we did force diagrams, we had, look on table right here, we have books pushing down on the table with a normal force. Table pushes up on the book with the same magnitude of normal force. And I'd say we are done with chapter 5. Which means two things. One, quiz on chapter 4 and 5. Chapter 4 is Newton's second law, chapter 5 is Newton's third law. So let's establish when the quiz is. So I guess you have a quiz on Wednesday. Oh, that's right, I was gonna give time today. Oh. All right, still didn't do it. So let's put the quiz, the homework quiz on 4 and 5 together on Monday. All right, so the test is up through chapter 5, the first test. Two schools of thought. One school is before you cover too much new material, it'd be nice to actually have the test on the first material. The other school of thought is give a little bit more time to study for the test. So, let me ask you, when do you want the test? Because I can just make something up if I need to. Old tests.
Oh.
It's gonna be on chapters 1 through 5?
2 through 5.
And 2 through 5. 30, I vote 30.
30th?
Uh-huh.
I have no problem with the 30th, we'll be covering material that won't be on that first test, in the interim. Because that's 2 weeks away. But, anyone want to propose something else, otherwise we'll look at the 30th.
That gives me anxiety.
The 30th, that's too far away? We can do the test on Wednesday if you want.
Too close. What about the 23rd? I mean, what about Friday? Well, Saturday.
Yeah, what about the 23rd?
Except, it's not like I have students who aren't in this class. I mean, we could do Friday, that's,
Monday the 28th. Oh, I won't be there.
What about the 23rd?
alright.
Pick a day.
So we got Monday, Wednesday, Friday, that's 21, 23, 25. I guess 21 is out, because we have a quiz that day. And then 28 and 30. All right. So what's the 23rd? 25th. 28th. 30th. Let's go by. And Manal, you said you were not gonna be
I
here.
can't, I have an orientation for work.
Don't you wanna tell them that this is far more important than anything they have to tell you? Test 1, hang back after class just a couple minutes and we'll figure out the plan B. All right. If the 28th is a hardship for some reason for those who wanted it earlier, then talk to me and we'll see if we can come up with something that works for everybody. And I believe there was also the request that we spend some time working together on, that you can work together on the remnants of the lab. So let's go ahead and do that one. Sorry I didn't think about it earlier. But you got 20 minutes. Let me grab face shields.